Hey people, this is Dan Ruben. Today I'll be presenting to you Face, the 50-ish% implementation of FaceBlind. So what is this FaceBlind thing supposed to be? Well, FaceBlind is a privacy-focused, modularly designed real-time C++ object sensoring system, intended to make privacy easy to keep while making videos. Now, to begin, this program currently builds entirely through Qt Creator. You just make some minor configurations, wait for it to install all of OpenCV and a few small dependencies. Takes like a half an hour to upwards of an hour, depends on your internet really. And at the same time, you just follow the installation instructions on how to set up your OS. You just install a few things really. Especially note the fact that you need Visual Studio build tools on Windows, because in fact VCPKG hates MinGW. Now, once it's built, you can directly run it through Qt Creator as well, and you'll be presented with this main menu. Consistent styling is done through QSS, and we have the options: start webcam stream, load video file, settings, help, exit. So to begin, settings, it's a lie. But all the rest, they're not quite lies. So help, you just get some basic help. Exit, you directly exit the application. It also completely closes it as well. And then you can easily run again. And then start webcam stream, load video files. I haven't quite figured out how to make it relative to it yet, so please understand. And so to begin, the real meat and potatoes, start webcam stream. So to begin, once you start, it asks for permission, you allow, and then wait a little bit, and then it initializes hello. So now, as you can probably tell, it's going through things, you know. But even if this kind of little ventriloquism thing is interesting, but it's not quite there yet. That's why it's just kind of 50%, you know. And you can also load in video files such as this beautiful stock video I have here. Video loaded successfully, and behold, still choppy. But hey, at least it's able to draw these cute little boxes around the objects it detects. It's not quite there with occlusion yet either, but I'll get there one day. So as you can see here, you've got application output for debugging purposes. And currently, inference FPS hovers around 2.4-ish. So that's my main bottleneck. And in fact, it was hovering at around 2.2 just a little while ago until I statically linked all my libraries. So, which led to a 10% increase to 2.4 FPS. Yippee! So now, in terms of patterns. Now, hold on. Let me just read through my script a tiny bit more. Yeah. Oh, yeah. Okay, so my next steps for this is implementing the SORT algorithm, which should allow me to have more or less reasonably good filler tracking for predictable constant movements between detection cycles. Hopefully, I can optimize it such that it roughly runs at 30 FPS, especially the tracking boxes. They should work very well with constantly moving objects. It probably won't handle occlusions too well, but again, that's kind of a skill issue on the part of the video maker, not my problem. Now, besides this, basic multi-threading was used to prevent the whole app from feeling choppy as the videos. Essentially, you've got the decoder, inference, and the GUI support. They all get their own special threads. And now a quick run through on the patterns. You've got consumer producer. Hold on. I need to actually find this. Yeah, okay. Consumer producer. So consumer, let's see. We've got the raw frame buffer here, tracking.cpp, a facade. I'll get to that later. It consumes the raw frame buffer in order to process it, and then it produces to the processed frame buffer. And then afterwards, you've also got the facade patterns. Essentially, each subsystem they only present a facade to externals. Essentially, each subsystem, they have a specific set of purposes. In order for other subsystems to access these sets of purposes, you go through the facade. It's more or less the gatekeeper. It just keeps the cohesion low, make sure that nobody knows too much of anybody else, you know. And then we've also got the long beloved factory patterns. I use one for readers currently. I'm planning on making it also work for writers in the future. Maybe I'll like make a separate one honestly, but not really too sure yet. And then afterwards, we've also got a factory for the detection models. Essentially, I want to be able to experiment with different models as well. Oh, by the way, you need to actually you need to actually run a Python script in order to like download all of the in order to download the actual detection models. So like that's an extra bit of configuration. It just takes a few minutes, honestly. And then yeah, you've got this factory as well. And then you've also have the observer pattern, just like inherently built into the Qt framework. Essentially, like you just have signals that connects to certain slots, and essentially, like whenever a event happens, a quote unquote signal is sent, which essentially just runs this dedicated function to that signal. It allows for easier asynchronous communication and whatnot, especially between the front end and the back end. And then in addition, there's like another kind of inherent pattern, kind of. So essentially, one of the optimization strategies I'm going for is also the curiously recursing template pattern. Essentially, it's just like you use templates in order to get rid of some of the runtime overhead into the compile time. So essentially, like all it takes is just like you compile it for longer, but the user should hopefully be able to do this stuff faster. And there's like all sorts of like polymorphism stuff like that. So essentially, in order to do this, I'm using standard visit, which essentially is just the visitor pattern. It's just like you don't really have a dedicated accept function. You just like create a lambda on the spot, depending on the standard variant. And like more or less it works the same. It has the same benefits of just like being able to easily extend your stuff. Or you just simply add more of your template interface, or more of your concrete classes to the template interface to a standard variant. And yeah, that's about it. And then that's in terms of patterns. Now in terms of future, as I mentioned, I want to get the SORT pattern sorted. I want to also let's see. Okay. So now next steps include person and also the personal observer pattern. Yes. Such that I want to implement an event bus system, which would allow me to do more advanced multi-threading, just like each subsystem or like some sort of a resource intensive event task, whatever, gets their own thread, and then essentially just communicate between each other through like sending signals to the event bus that sends signals to the others that are dependent on certain things. And then maybe like experiment with like some sort of region of interest detection around the SORT predicted bounding boxes to maybe more accurately track while keeping the overhead slimmer. Then also putting the bounding boxes into a flyweight, reduce overhead that way, reuse the stationary bounding boxes, actually drawing in assets as this project specifications should, and actually saving the webcam videos and edited videos. And like some other like nose curiosities and whatnot to talk about is yeah, I think like more or less I want to be able to just oh yeah, I want to also like maybe make all of my interfaces from now on just compile time polymorphism as well, just through like CRTP like I did with that experiment. It seems to maybe work a bit better. I can't really tell at this point, honestly. And like some other notes, maybe I'll try like Siam TPN. It seems to I should be able to just like whip up a quick Python script to download it as well. Then just like load it in through the model factory. Maybe just like make it work in tandem. And yeah, that should be about it roughly. And yeah, that's all, folks. See you after I die from finals, Lamel.